amigos. Estaba hablando con Juan Pablo hace unos meses y estábamos haciendo chistes sobre hacer esta presentación en español. Unas semanas después, él publicó este tweet. El único problema es que yo no hablo español. Entonces yo decidí hacer un pedacito de la presentación en español y cumplir mi promesa, pero volveré a inglés en un minuto. Hola a todos. Alex me pidió a mí, Juan Pablo, que la tradujera su introducción. Les habla Juan Pablo. En este momento, él piensa que está leyendo algo sobre el gran honor que siente al estar en Colombia, pero no se aseguró de revisar si yo había traducido correctamente. Como pueden ver al leer cualquier cosa que yo escriba aquí, miren esto: piña, avena, gasolina. Me gusta la gasolina. De cualquier forma, creo que es mejor que volvamos a su presentación normal. Estoy muy feliz de hablar con todos ustedes. Voy a hablarles de seguridad web, lo cual puede ser un tema miedoso para muchas personas, pero espero que lo encuentren interesante. Gracias por aguantar mi terrible español por tanto tiempo. Back to English. Thanks, Juan Pablo, for an excellent translation, I assume. I was worried I was going to say something wrong and then I'd be muy embarazada. So I'm talking about security, and security has a lot of baggage, a lot of things that come along with it. And when most developers see the word security, they say something along the lines of, security is very important. Someone who knows about security should take a look at all this code I'm writing. We push security outside of our jobs onto other external people. And I think a lot of that has to do with the crazy amount of acronyms and jargon that exists in security. So here's a few for you, in English letters though. CSP, SRI, CSRF, XSS, CORS, you say CORS, you don't say CORS, I don't know the rules. HSTS, there's like 50 more. I could keep going, but I'll get started with kind of an analogy to let you know why I think it's important for you to learn about security and why maybe it hasn't traditionally caught on. So I work at a company called Stripe. We do payments. It's not very important. We should be secure if we do payments, though. It's in California, but I live in Texas. Texas has a lot of nicknames. Right now we'll go with Lone Star State. That's the safest one. But the web also has a lot in common with Texas, such as another nickname, which is the Wild West. The web is often referred to as the Wild West because you can kind of do whatever you want, which means that security can often be a problem. And in 1985, Texas had a problem. Texas had a lot of problems in 1985, but right now we'll go with littering. And you wouldn't imagine that littering is something that people disagree on very much, but some Texans defended their God-given right to litter. So we made fines for littering. $1,000 fine for littering. No one seemed to care. And then they tried some slogans to try to work everybody up. This is the first one they tried. Keep Texas beautiful. And it's very nice and it's very pretty, but the people who were littering didn't exactly identify with flowers and the pretty please keep Texas beautiful, won't you, oh please. So these slogans didn't resonate with the people who were doing the littering. The people who were doing the littering were males, 18 to 24, who were actually in the government paperwork described as bubbas in pickup trucks. I don't even know what that means, but it perfectly describes them, I think. In 1985, Texas tried something slightly different. There was an advertising agency they worked with to try to make things better, and they came up with Don't Mess with Texas. Have you guys heard of Don't Mess with Texas? No? No? Well, it's pretty popular. It's in songs, it's on movies. Most people don't even know that it has anything to do with littering. They just are proud of Texas and they say, don't mess with Texas. And they don't know what it means, but it was actually for littering. But it worked. 72% reduction in litter over the course of 4 years after that advertisement came out. Which first brings me to my first question, which is, whose job is it to count litter on the highway to get this number? And also, if they're already out there counting all the litter, why can't they just pick it up? But my point is, we can't do the same thing for security. Hey, everyone, pretty pleased with the cherry on top. You should make your websites more secure because it's important. That doesn't resonate with web developers like you. Sure, maybe it does a little bit, but it doesn't make you change what you do in your job in order to get things done quickly so you can move on to the next task. We're always behind. So another phrase that might not work is, don't mess with XSS, which is similar. So web developers, you all are the audience of security learnings, not security researchers. But generally, security people talk about security and web developers talk about web development, and there's very little crossover. So it's probably because web security is very hard. There's a person named Mike West, and he says, all you have to do is never make a single mistake. It's pretty good. There's another guy, Alex Russell, says, I discount the probability of perfection. Now, if you think of both of those at the same time, you might understand that we're probably going to have a few security holes. One of the primary ways that security holes enter applications is through content injection. Content injection sounds like a big word, but it's really like injecting content. So that might look like this. You have a template, this is handlebars, and you ask some people, for a link. You type in some HTML with your bio, and you can link to your Twitter account. And so you allow them to put some content. You have some data, and you put that data through the template, and someone types in a script tag, and then whenever you render it, it comes out as a script tag right in your HTML, and then whatever code they ran can run in your page. It's the classic XSS attack. That's cross-site scripting. And that means that now they can do anything that they want on behalf of the user that's logged into your page. And that's very bad if you deal with payments or really most things if you just want users to be happy using your website. So this is bad, and we want to prevent this, but there are lots of other ways that things can go wrong. Everyone I know seems to have one friend that picks, this is gone. Do a dance now. Ah, smart. Bien.
Mejor?
Mejor. I guess. Lo siento. Everyone seems to have a friend that picks a script tag as their username whenever you try to write an application, just to see how good of a job you did. And to that effect, I have a friend. This is my user agent. And let's ignore the fact that user agents are insane and nothing in there makes any sense. But this is a pretty general user agent. This is Chrome, obviously. Mozilla Intel, Apple WebKit, KHTML, Gecko, Chrome, Safari, but it's Chrome. This is my friend Mike Taylor's user agent, which looks pretty similar, but if you look closely, he's got a script tag right in the middle there. And that's funny, and I thought that was like a really good idea because your user agent goes along with every request you make. But then I realized that no one like puts out your user agent on your website, so really he's just like trolling logging software, which is cool. That's one thing you could do. Anyways. This is Sammy. I don't know Sammy, but Sammy gained some notoriety in 2005, quite a long time ago, with what was called the Sammy computer worm, or JS Space Hero is what Norton Antivirus called it. It was a virus that worked on MySpace. It was a worm. It was one of the first JavaScript worms that someone wrote that was successful, and it was completely harmless. All it did was whenever you went to Sammy's page, it would run some JavaScript that it was able to inject into the page, kind of like we saw before. And it would make you friend him, which is fine. So now you're automatically Sammy's friend. And then he would go onto your MySpace wall, whatever MySpace had. I don't know. Is it a wall? Probably. You go to your MySpace wall, and he'd write, "Sammy is my hero." So two things happen. You get friended by Sammy. You guys friend each other. And then you write "Sammy is my hero" on your wall. But also, whenever you write "Sammy is your hero" on your wall, he does the hack again on your wall. And so anyone who goes to your page now friends Sammy and writes "Sammy is my hero." And so in like the first hour, he had like 60 friends. And then the next hour, he had like 100,000 friends. And the next hour, he had like 1.7 million friends. And then his account got deleted. And MySpace called him out and said, "Hey, you should work at MySpace. You're clearly a very good engineer." So he flew out to San Francisco, and when he got off the plane, they arrested him. If you read this, you can go to this page on Wikipedia, but he actually got like convicted under the Patriot Act, and he wasn't allowed to use a computer for 3 years. But, yay! But whenever he was allowed to use a computer again, he wrote something new called EverCookie. EverCookie's pretty nifty. You guys are familiar with cookies. You need some data to be there the next time you load a web page, and so you store it in a cookie. You read it back out the next time. And people can clear their cookies. Everyone's pretty used to that. And what EverCookie allows you to do is to store that data in more locations. You can store it in Flash, in Silverlight, in CSS, in Java, window.name, old hacks and exploits, and he stores one piece of data in every single one of those. So if you think you cleared your cookies, he'll just go grab it out of Flash. If you think he cleared Flash, he'll grab it out of a Silverlight. You can keep going and keep going. And he has an FAQ on his page. How do I stop websites from doing this? Great question. So far, I found that using private browsing in Safari will stop all EverCookie methods after a browser restart. And that was it. Otherwise, he could always get the data back. I also found one other method, which was just setting your computer on fire and buying a new one. So that's pretty interesting that, that this could happen. And this doesn't really have a ton to do with XSS, but it kind of shows that once you can kind of get on a site, you can have like thick memory, and there's all sorts of scary exploits that can happen on your site if you allow content injection. So let's just detect which scripts are bad and which scripts are good and kill the ones that are bad, right? Pretty easy. So can anyone tell me, is this script good or bad? Not a lot of hands. So this JavaScript is perfectly valid. It would execute in your browser if you ran it right now. And of course, it is an alert 1. So not the worst JavaScript, but probably would maybe make your users confused. You have to do alert 1 because anything bigger than that gets really, really big. Another one, you're like, oh, well, I'll just remove any scripts that are only square brackets and pluses. That'd be pretty easy. But here's one of my favorite attacks. Here it is. Here's a whole hack right here. It's right in this section here. There's the malicious code right there. You see it? It's pretty hard to detect even with your own human eyes. That's a tab and a space and a tab and a tab and a space. It goes on pretty long, but it still looks like white space, right? And then if you can get an eval into the page, then that can be a 1 and a 0 and a 1 and a 1 and a 0. And you can take that into ASCII and then execute that ASCII through eval or a new function. So if you have a templating language on your page, someone could run this code through the templating language, and boom, there's your malicious code. So in conclusion, you cannot detect malicious code. You can, certainly doesn't hurt to try, but I wouldn't rely on that as your sole method. So what if we just stopped anyone from ever being able to put a script tag in the page? That seems like that would fix content injection, right? So you have your output that you're about to render from the server, and you replace all script mentions with an empty space. Seems good, right? So I'll just inject one of these images that loads a bad image, and then on the error handler, it's going to alert anyways, because you can run JavaScript inside of inline handlers in HTML. And so I got around that in one fell swoop. Not to mention that if you block any images, I can even just put a URL into your website. If I'm not allowed to put HTML, but you ask me for my website, and I give you my website as JavaScript:alert, as soon as you click on my website, I can run any JavaScript that I want. I can load external JavaScript files and pull them in and do all this stuff. And you're really going to probably click on this URL, I imagine. I wonder how spell check missed that one. Sorry. So even if we disabled JavaScript in our browsers, we wouldn't be free. CSS has plenty of vulnerabilities that we can use. For instance, history knocking. History knocking is whenever you can use a property about a link you visited and compare it against a link you haven't visited. And so let's say I injected, 3 million links into your page, maybe hidden off the side of the page. And I went and checked every single one of those links to see if they were purple or blue. And I knew that you had been to all the sites that were purple and not the sites that were blue. And there may be sites that you don't want me to know that you've been to. But there's even some crazy stuff you can do by just guessing 3 million different Google searches and seeing what you've been Googling for, because Google has just query parameters at the end of a string. Lots of scary stuff that you can do here. This has mostly been fixed in modern browsers, actually, in the naive case. So this is the visited selector. This is a guy named David Barron kind of fixed it. The way that they fix it is they just lie to you. If you ever ask for the styles on a link, they're always going to tell you that it's never been visited. And that has to work for children because the visited selector is kind of weird. There are some ways you can get around it, but it's pretty good. One of the ways you can get around it, though, are timing attacks. Timing attacks is another fun area that we haven't covered yet, so I'll give you the primary use case in the past, passwords. So if we wrote a loop in order to check if our password was the right password, so in your code, it's the login screen, and you want to see if the password they typed in is the same one that you have stored in the database. And you just go character by character. Is the first character the same as the first character of the other one? Is the second character the same as the second character of the other one? And so forth and so on. The problem with that is that for passwords that are really wrong, you fail very fast. And for passwords that are almost right, you fail slower. And so if this is the password, which is all my passwords, please don't use it. And I tried to guess your password, and I used all A's. That would fail pretty fast, because the first character doesn't match the other first character, 0 milliseconds. In this case, we have 2 characters right, and so it fails a little more slowly, so we know we're on the right track. And we can keep going. It fails a little more slowly until we have the full password. So you just keep trying, you kind of brute force it, but it can happen pretty fast. And there have been banks that have been broken by this, which is why it's important to do like bcrypt and hash your passwords and all that kind of stuff for many reasons other than this. In the past, timing attacks haven't been a huge problem on the client side. The biggest reason for that is because we had really crappy timers. We had set interval, right? And it was very bad. So I call that security by inaccuracy, which is nice. But now we have better timers. Request animation frame you might recognize from some of the animation demos. And then our friend the visited selector. And we can still kind of maybe do some link knocking. So here is my hack. Here's the new hack. You have a visited link that looks different than the other link, but the browser's going to lie to you. So how can you tell which one's visited and which one's not? It's because this one is very fast to render, and browsers are very bad at rendering text shadows. So with request animation frame, I can see which ones have been rendered and which ones haven't been. And this can never be fixed. The only fix for this is making this one slow. And I don't think they're ever going to do that. So the only nice thing that I can tell you is that it takes a long time to do this hack, because this takes a long time to render. So it's a lot less efficient than the old hack, but I don't think it's ever going away. JSONP. A lot of you use JSONP on your websites for cross-domain things. Have you used JSONP before? Yeah, lots of people. Pretty cool. Side note, Douglas Crockford created JSON. I say JSON. Some people say JSON, and they fight each other on how to say it. But Douglas Crockford, a few years ago, actually said how you're supposed to say it. And he said it's pronounced JSON. So it's also GIF. So I actually don't like JSONP very much because it's pretty insecure. A lot of people don't realize what's happening behind the scenes of JSONP because it's a very well abstracted thing, right? It works very well. You don't really have to know about the details of what's going on behind the scenes. But if you use JSONP, you might say something like, I'd really like it if someone or anyone could run arbitrary dynamic scripts on my page. Of course you wouldn't say that, but that's exactly what you're doing whenever you load a JSONP. This looks like AJAX. You call the jQuery AJAX function. It looks like just a different data type. But really all that happens is you load a script tag in your page that has a callback in it. And let's say that callback is this one, and you call it back, and you have perfectly good data, and it just so happens that someone steals your social security number right before them. You guys don't have social security numbers, but I promise they're important, to me at least. So a solution to that is CORS. So CORS, we talked about before, stands for cross-origin resource sharing. I won't talk about it too much, but it allows you to do real AJAX across domains as long as the domain knows you're going to be doing it. You can go to enable-cors.org, and it will explain how to set it up on Apache or Nginx or something like that. So if we just protect against JavaScript and script tag injections, we're good. So we talked a little bit about CSS knocking, but that still requires a little bit of JavaScript to at least test which links are which. But in this case, you often might have a form with a CSRF token. These are probably generated by whatever framework you use. But it's an important value. It means that if I make a request on your behalf and I know your CSRF token, I could do anything I want for you. Let's say I was able to inject some CSS. This is some nifty CSS that grabs any input element with the CSRF class. And if the value is 0001, then it'll load a background image on my website. And then I'll get a request on my website saying that 0001 from this IP address was just loaded. And so now I know your CSRF token and your IP address. And that seems kind of crazy, but what if I put 2 in there, add 3 in there, and then we're back to 3 million injections. But actually, this gzips very well. It's pretty much the same code except for the little section. So core use case for gzip. But it doesn't even stop there. Even if you do everything right and you can stop against all this stuff, there's something that some people wrote about pretty recently called SVG, like filter, OCR, hacking. A lot of acronyms there. Pretty much they're able to overlay an SVG over your iframe of your web page and then create an image that pulls out the text, and then they used image to text rendering to figure out all the text on your web page, and there's nothing you can do about it. So we need a different approach. We can't keep looking into each different method that people can hack us. We need to lock everything down and stop everything all at once, and then maybe poke a few holes for the things that we actually use. And the way to do that is content security policy. It sounds pretty scary again. And because of that, some of the people who work on CSP are thinking about changing the name. So to increase CSP adoption, we're renaming it to BATShield, which is back acronymed Trustworthy, Secure, Internet-Enabled, Lightweight Defense, which you will notice does not have an H. So she fixes it. I forgot the H. It stands for helper. Seems good. This was a helpful diagram that came along with it. That's how it works. So this is BATShield, also known as CSP. So it's a header. It comes along with the headers in your, so cache headers or URL headers, things like that. And you can define different rules for different types of things on your page, for script tags, or for images, or for CSS, for fonts, for AJAX, for every different type of way that you can talk to a different server. And then anytime anyone breaks those rules, you can have it report back to you. So for alexsexton.com, there's a bunch of headers that you can't read, but here's my content security policy, which is ridiculous because I have nothing on my web page worth stealing, but it makes me feel cool. So check that out. Try to hack my website. Don't try to hack my website. Not a good thing to tell people to do. So by default, it disallows all inline JavaScript and CSS. So a bunch of those categories of problems where we couldn't detect this or couldn't detect that go away because they're just not allowed. You're not allowed to write inline CSS, and neither are the hackers. And if you do, it gets reported back to your server. By default, it disallows eval, or new function, or any way to take a string and execute it as JavaScript, which gets rid of that nasty white space attack. It disallows cross-domain JS and fonts and images and all these things, even iframes, which disallows that crazy SVG hack if you don't allow yourself to be an iframe. And so that's kind of crazy. It by default stops all these things. Now you have to open it up in order to get your images off your CDN and to get your fonts off of Google Fonts. But hopefully you can leave a very small whitelist of sites you trust versus any old location. And most of all, it's best that if anyone finally finds a way to get through this, you'll be notified about it. This is not my real report URI, so send as many curl requests to that as you want. A whitelist is the key. The fact that everything is closed off by default and we allow a few key external sites to access us is better than allow everyone to access us and make sure none of them are doing anything funny. CSP has been out for a while. It works in all major browsers. I run it on my site. Stripe runs it on its site. Lots of companies are moving to it. And CSP 2 is coming out. There's some stuff that allows us to now do some very specific inline scripts, things like that. You should read about it. There's this website called cspisaawesome.com. It will help you generate a content security policy for your current website. There's things like Helmet, which is an Express or Connect. Like if you run a Node server, then you could pull in Helmet. It'll help you just inject content security policy headers. There's something like Ember CLI content security policy. It's included by default in Ember. And if you use Ember CLI, then you'll automatically have content security policy on, which is fantastic. There's also something called SRI. That's sub-resource integrity. And that says, all right, we made sure that your website got here, but then you loaded a bunch of things like off of CDNs and external servers and font servers. We have no idea if those servers have been compromised. And so what you can do is make sure that all these other resources on your page are the ones that you're expecting. And so it's pretty simple. You can use a generator to do it, but it takes the contents when you build your web page and says, I expect this image to be exactly this. And if the image that gets downloaded isn't that, then it just doesn't load. And that's pretty it. That doesn't seem too crazy, except for one time, this is real. I went to the UK, and I was loading a page, and there were advertisements on. I know that page didn't have advertisements. And I looked into the jQuery source, and this was on the jQuery CDN. And I looked closer, and I looked closer, and I'm pretty familiar with it, but this does not look like jQuery source code to me. And what it was someone capturing the request, injecting this stuff that would inject ads into the page, and then passing the request along. So sub-resource integrity would stop this from being possible. You can read about it in the spec, which is somewhat boring. You can go to SRI hash generator, srihash.org, srihash.org, and you can take any source and it'll generate the correct hashes. You can read up on it on the Web Application Security Working Group because it's still kind of in flux. So good security goes beyond just content injection. I don't have a ton of time to talk about how to tune your server, but I have some overlaying notes that I'll go through quickly. So you should do secure servers everywhere, HTTPS everywhere. And I actually don't like the term HTTPS everywhere, even though I used it. I think you should do HTTPS only. So if someone tries to access your site over HTTP, then move them over to the secure site. Don't just serve it there for no reason. You can do things like HSTS, which make sure that no one can ever go to your HTTP site again. And then you can also talk to the browser vendors via this beautiful web page. This is a Chromium web page where you can type in your URL, and you'll say, in the browser, in Chrome source code, I promise to always only serve my site over HTTPS. And then if someone tries to go to your raw website, the browser won't even request the first one. It'll just automatically move you over to HTTPS. So in the beginning, that was like Stripe was in there and some banks, and there were some Google websites that were in that list. But they kind of opened it up on this secret. It's not a secret. It's just a boring mailing list. But I saw, and so I added alexsexton.com, and so it was like, there are lots of headers you should look up. I don't know. I really want to tell you about them, but maybe next time. So security by default is kind of the core idea here. Don't try to detect all the places you're insecure. Try to be secure by default and pull out those little insecure places. So you can rely a little less on being perfect, because if you make a mistake in a vacuum, it's fine. But everyone has to buy in, so don't mess with the web. So, not very creative. So let's do something about it together. Let's make our sites secure with CSP. Thanks.